This is problem 12.11 from Brigham in Houston, Fundamentals of Financial Management, Concise 9th edition, replacement analysis. The shipyard is considering replacing an 8-year-old riveting machine with a new one. The new machine will increase earnings before depreciation from $25,000 to $46,000 a year. So the increase in pre-tax, increase in EBITDA, earnings before interest, taxes, and depreciation, would be $21,000 per year. All right, the old machine's fully depreciated, so there's no more depreciation expenses, but the new machine would be depreciated over an 8-year period. The new machine's going to cost $80,000, and then the depreciation expenses in years 1, 2, 3, 4, 5, 6, 7, and 8 follow the MACRS rules, and that would be 20%, 32%, 19%, 12%, 11%, then 6%, and then 0% because it's fully depreciated. All right, so the depreciation expense would be the $80,000 times these percentages, all right, so we got depreciation expenses in each of the next 8 years that we didn't have before. The EBITDA will go up as well. The old machine, there's no salvage value, doesn't say, and the new machine will have no salvage value. So essentially, our initial outlay be negative $80,000. All right, and I don't see any other expenses. Okay, so that looks like it. Got a weighted average cost capital of 10%. All right, the after-tax operating cash flow, the change in EBITDA would be positive $21,000 for each of those 8 years. Depreciation expense would be $16,000. $25,600, $15,200, etc. The depreciation expenses we already calculated. So that'd be the change in EBIT would be the increased profits less the depreciation expenses from the new machine, and the EBIT times 1 minus the tax rate, and then add back the depreciation. And we're using a tax rate of 40% on this problem. So that times 1 minus the tax rate, and then add back the depreciation expenses. And make sure I highlight everything. There are no terminal cash flows here. Once the machine is all used up, it has no salvage value. So there's no increase or decrease or any change in the working capital. So essentially, our terminal values are essentially zero. All right, so we just didn't have any. So now I've got all three of the component pieces. Total cash flow be that line plus that line plus that line. And I set these things up the same way every time, and even if they got zeros in there, that way I can make sure I didn't forget anything. All right, so when I do a spreadsheet, if there were no terminal values, rather than leave that out, I go ahead and write it down that there were none, and that way if I screwed something up, it's easier to go back and find it. All right, we're given a weighted average cost of capital, and I believe they're using 10%. So if I calculate the IRR for my project here, it's going to be earning 14 and change and only costing 10. Okay, so I've got a nice cushion in there. Just want to make sure what my weighted average cost of capital of 10%. Okay, and then calculating the net present value. The present value of the future cash flows, 10% is $91,000. The initial outlay is only $80,000. So my net present value is a positive $11,961. So replace the machine because the NPV is positive and IRR is greater than weighted average cost of capital. And that's your decision rules. And that's problem 1211.